Alright, welcome back. So now we're on to the next chapter of this tutorial series. We're on to particles or pops. So welcome to Intro to Pops. What pops is basically a particle system in Houdini, and that's how particles are represented. It's points. It's probably constantly a thing that I use the most in Houdini while working. And it's really powerful for most of the effects you want to use. Even if you're doing like a smoke simulation or a destruction or anything like this, you will at some point during these things use particles. So this is definitely one of the most useful things. And I'm gonna go over how a particle system works, kind of a couple of the most important nodes, and how to just start your first simulation in POPs. So this is example one. Let's take a look. So what we're gonna start off doing is we're just gonna drop down a geometry. I've dropped on a sphere here. Scale it down a little bit, and then we want to drop down the actual pop net. How we do this, we type pop network, and we don't want to do old, we want to do a new one, and we click enter. I already dropped down one here and named it popnet. So basically what this is a dopnet. Don't get fooled by the name. Popnet is just the artificial name that I created. The actual name for this is called dopnet. That means dynamic. It's basically the dynamic context for Houdini, which we use for simulating anything, water, flip, pyro, RBD, anything like this. And particles also live in there. Anyway, let's dive in and take a look. So this is basically a couple of nodes. I made notification here, sort of explaining a little bit, but what you get when you drop down a popnet that is clean and fresh is these 4 nodes and this node. So I'm going to explain quickly what these are. These are let's start from here. A merge that merges in all the couple of the streams that are from the popnet. A pop object, which is basically just defining sort of some dynamic properties of it, like bounce and friction and stuff like this. The actual pop solver that actually takes on in all the points and all the velocities and makes the magic happen. We can dive into it and see some things going on, but I'm not going to go into that because it's a little bit more over course. And an output, that basically means that everything that is connected to this goes out of the dopnet and out back here. Anyway, so let's take a look at the node up here. This is also one of the nodes that you get when you drop down a fresh popnet. It's called the pop source. This is one of the most important nodes for the popnet, because this node is what actually takes the geometry from the outside of the popnet and brings it in and kind of does the magic inside of it, like simulates on top of it. So let's say we want to bring in some points. We have a couple of options how to source the points, and I'm going to go over them really right now in the source tab here. So what we're doing right now, we can see in the viewport here, we have a bunch of points on this guide surface. I'm going to turn this guide surface off because it's kind of distracting, but just know that the guide surface is the actual object or the points that you're sourcing from. I'm going to turn it off like there. So what we're doing right now, actually I'm going to keep it on for this. What we're doing right now, we're sourcing points from the surface because we have emission type put to scatter to surface. This means that we will randomly scatter points onto this surface that is connected here. That's all we're doing. It's random and it's doing like that, basically. Another emission type is called points. What we're doing here, we're basically taking each point from this geometry, which means that, as we can know, we have these points. And instead of taking the whole surface and scattering on it, we now only take the points. We grab those and we simulate from it. And it's going to look like this. It looks kind of similar, to be honest, but and my favorite way to source the points is all points, because then you have way more control. This means that up here you can actually control. So let's drop down a scatter, and we go to it, and now we have 1,000 points. We can turn off relax iterations. We have 1,000 points here, and we are sourcing 1,000 points. And this is because we put it all points, which means it will source all the points coming in. We now have no control in here about how many points we want to source. The only way we can control it is up here, but it's in my opinion, a better way to source it. Anyway, we're gonna go back to emission type scatter onto surface, just to keep it simple. And then yeah, that's basically the most important things for the source tab for now. I might go over source group and emission attributes and stuff like this later on, but for now we're gonna keep it at this simple. So source tab, it just defines how you source the points. In the birth tab, let's go over here. We have some more options here. So here we have a bunch of attribute sliders here. It might be a little bit confusing. I'm kind of confused by these sometimes as well, but make no mistake, they do different things. And these two top ones, when you do emission type scatter to surface, doesn't matter. Like, we don't use these two. The only ones you should be concerned about if you do scatter to surface is the last two here, constant activation and constant birth rate. Constant birth rate basically defines how many points we scatter onto the surface of the incoming geometry. So if you up this, we can see the points increase a lot. We're gonna keep it kind of lowish. Let's keep it to 5,000. Constant activation means that if it's 0, we're not sourcing anything. If it's 1, we're sourcing everything. Let's try it. 1, we have points, we're sourcing. Let's put it to 0, we're sourcing nothing. So that's basically just an on and off switch. If we instead put it to all points, we're now sourcing the points from the the actual points from the geometry. We can now see that all of these are off. Like, we can't do anything with them. The only thing we have control over now is the impulse activation slider on and off. We can turn it on, which is 1, and off, which is 0. Simple as that. Let's turn this back to scatter on the surface and check out more here. So these we kind of know what they do now. Let's see. So we just one group. We're not gonna go over now. I might take it in a later lesson. It's kind of useful for some things when you want to do things on the first frame of simulation, but never mind that. Seed is just the point seed when we're scattering. Life expectancy and life variance is really important. So we have talked a little bit about attributes, and another attribute for points in a pop simulation or particles is the age. So the age is basically how long a particle can live, or life is. Age is just how long they live, but this is how long they will live before they are erased and die, basically. So if you put this to 1, they will live for 1 second. And since we have our frame rate to 24, we have 24 frames per second. So if we scroll, we're gonna see after 24, they start disappearing, as you can see. That's very cool. And then we can have some life variance. We can put this to 1 as well. And this means that some of them will die in frame 1. They will die immediately. And some of them will die after 2 seconds. So we can see that the longest they can go is after 48, they start dying. The outmost particles out here. That's really cool. That's how you set up that. We're gonna put it back to the original 100. We're gonna go back to 0 frame. So now on to attributes. So attributes is kind of interesting as well. Here you can kind of source. We're gonna put the inherit velocity at first. So inherit velocity, we kind of grab a velocity attributes from the geometry. And this means that we kind of have to set up one. So let's drop down a point op. Let's drop in here. Let's add a constant. Let's put a vector upwards in Y. Let's go back to popnet. And now we're actually just sourcing the V attribute here. And inherit attribute, and we put it to 1, the multiplier. And this is just a multiplier. So if we put this to 10, it will multiply the velocity incoming by 10. But we're going to put it to 1 to multiply 1. And now all the particles are going upwards, like this. That's pretty cool. There is a couple other ways. We can also do add to inherited attribute velocity. This means that we can also, while we're sourcing the velocity, we can also add stuff. So we can add 1 in X and add some variance to that, 0.5 and then 0.8 in Y and 0.1 in Z. This can give us some kind of interesting velocities as well. And then obviously we can go to the last one and we can actually set the initial velocity like this. And at this point, we are not factoring in our inherited velocity at all. We are just using these vectors and these variants right here. And then add ID attribute, always have this checked on. This is checked on by default, but this is super important to keep checked on, because IDs are very useful to use when you want to modify particles later on. But yeah, stream and bindings doesn't really matter. So that's everything for the source. And this is a default node that you get from every popnet, but it's very cool to use. Anyway, so I'm gonna set these back to the original. Actually, let's keep it at like just a positive x, like that, and see what happens. No, actually, let's keep it at positive y, like that. Cool. And let's give that some variance, just for fun, like that. Okay, cool. So now let's move on to some other nodes that are really useful. I'm just gonna check how long you. Okay, 11 minutes. They're pretty good. So, all right. Adding color. This is basically the same way as adding color in the SOPnet, which is up here. This is called SOP. This is DOP. This is basically the same way. You just add a vector attribute to your point. Simple as that. I'm gonna turn this on like that. Add the color red, 1, 0, 0, and the points are now red. Simple as that. Nothing, no real thing to it. It works the same way as the color node in the SOPnet. It has random, ramp, blend. We put it random to get random points from the ID. We're gonna keep it constant though, but yeah. So now the points are red. That's basically all this does. It can be useful to like do groups and like kind of visualize what's going on, sort of. That's what I use it for the most, to be honest, because you can always color things after the popnet, sort of. Anyway, let's keep this on. We have now colored the particles. Now we're gonna add another attribute with a node here. This node is called pop drag, and basically what this node does, it kind of slows particles down in a very cool and like artistic way. So we have a velocity to every particle, right? They are shooting upwards. They have the constant velocity. What we want is to limit these, and we kind of want to slow them down and bring them back to 0. And how we can do that is with a pop drag. And this pop drag will add an attribute called air resist. It's a float attribute, and you can add it yourself later on. I'm going to show you how to do that. But anyway, with the pop drag, we can add it. Air resistance, we put it to 1, and the wind velocity, that is a target velocity, should be 0, 0, 0, unless we want something else. But 0, 0, 0 means that we are trying to get our particles back to the velocity 0. Okay. If we turn this down, we can see that they are still speeding up a little bit, and they are slowing down. So down here, they are still speeding the same way, but then they start slowly slow down. And they're gradually slowing down, right? So they still have some speed here, but they're like slow and like, I don't know how to describe it, but it's very useful for things. When you kind of see that something is going too fast, you can just slap this on and usually it solves it. So that's a very cool node. I'm going to turn this off for now. We're not going to have it in our sim for now, but yeah. Next up, we have the pop force. So force is actually an attribute. It's a vector attribute, and it works really cool for gravity and for winds and stuff like this. But what the force pop can do is it can do multiple things. It can add wind with the force here. We're not going to do that now, but just know that we can do like that, which gives us some wind to our particles. But we don't want that. Instead, we want to add some turbulence. So what the pop force also have is noise here, and that gives us a very good starting point for adding turbulence to our popnet. We are gonna add the amplitude to 1. We're gonna put the swirl size to, let's say, 5, and pulse length to maybe 1.5, and see how that looks. Let's check this out. As you can see, we now have some pretty cool turbulence going on here. I kind of realized that my swirl size is a bit too big, so we're gonna put it 2. See how that looks. Still a bit too big actually. I'll put it to 1. See what's going on. Yeah, as you can see, now we have some turbulence and like they're going kind of crazy, but there's a lot of ways to control this. We can bring this down to roughness to have a more controlled turbulence. This is very useful to bring in some noise and make things look pretty. But yeah. Okay, I think that's all for now for this. You can play around with these noises and like get really cool results, but I'm gonna leave it for this like this for now. Put it back to original values. Yeah, let's keep it at 1. Okay, I'm turning this off. This is not gonna be in sim anymore. So next up we have the pop speed limit. What this one does, it actually simply does that. It limits our speed. We have a maximum speed and we have a minimum speed. Minimum speed and maximum speed. We also have a minimum spin and maximum spin, but that's a later tutorial. Spin is an whole other attributes. It's another thing. Let's talk about it later. But anyway, minimum and maximum speed. So we're gonna put the minimum speed to 1 and maximum speed to 2 and see what happens. Let's just turn this off for now and see how it looks beforehand. So it looks like this to begin with. Okay. If we turn this on, it looks the same. That's kind of weird. Okay, let's do that. Yeah, basically we can slow things down using this. If I put this really slow, like 0.1 and minimum speed to 0, we basically limit our particles how fast they can go. Because sometimes you will have simulations that seems to be fine, but then you have particles that shoot off like a million miles an hour. That's when you kind of want to bring in one of these to like kind of like confine it and take control over it and like kind of say, hey, nothing can go faster than the length of V10, kind of. But yeah, let's put it back. That's basically what this node does. It's simple as that. But yeah, let's turn this off. Let's go to the next one. So a pop attract. This is really cool. I don't use it too much, but I thought I would talk about it anyway. It's pretty interesting. So what I've done with this one, I'm gonna turn it on. So pop attract basically attracts your particles to a single point or an object or anything like this, and it basically has a position that the particles slowly tries to match. So we're gonna put the goal position of a point here to 1, 2, 0, a vector position of 1, 2, 0. So yeah, and let's see what that looks like. So let's see. So this point is gonna be somewhere around here, I think. Oh, sorry. Anyway, let's go. Okay. It's over here. Sorry. But anyway. And then it goes back. And then it goes back again. So you can get some really interesting effects with this. Like, really interesting stuff. And it's not like a straight attractor either. It's kind of like a gradual thing. So it can be really interesting. So this one I use sometimes when I have some magic effects to do or anything like this that I want more control over, but I just thought I'd show it. I'm gonna turn it off and let's go to the next node, which is my favorite one. Look at this. This is the pop VOP. Remember last chapter we talked about point VOPs and VOPs. You also have a pop VOP. This does the exact same thing, but in the pop or .NET context. So basically what you can do in this is, as I say here in the note, it's a joker. You can do everything I've shown you here so far. Anything in here. You can add air resist by doing a bind. If you remember, that's how you export attributes. You can do a constant. You can put it to 1. We can name this air resist float. And if we now take a look, we clearly have the air resist here. We can also, let's delete that. We can add some, I don't know, curl noise to pipe the position to the position. Probably noise, and we put that to the force. We put frequency a little bit down to 6, amplitude to 1, Just go with alligator noise and let's see what happens. We basically created our own noise to the force. What else can we do? Let's see, what else did we do? We did blah, 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 blah. We can limit our speed for sure. That's easily done. So we need to take the length of our v vector. We need to clamp that. And we just put this to 0.1. And now... sorry, I need to connect it here as well, sorry. Wait a minute. That's not how you do it. Or is it? Well, sort of. We can do it anyway. I didn't prepare for this, but yeah, you can definitely clamp things. You can definitely clamp the velocity and all these things. What else did we do? We did pop attract. We did pop drag, pop color. Pop color you can easily do. Just like this. So let's add another fancy color here. Let's do a blue. And since we did add the color here, after this we cannot overwrite the colors because this is later on in the stream. So if you play this, they're blue. Simple as that. Anyway, that's pretty much it for this introductory to PopNet. There's a lot to go over. I have a lot of things going in this course for now, so I hope you stay tuned for the next one, and thank you for watching.